Welcome back to another episode of Twisted Builds. So in today's episode, I want to show you guys a map sensor calculator I developed back in the early of 2024, maybe late 23. I wanted to start figuring out and developing applications for computers to work with the projects I was bringing to market on the microprocessor side. It started a lot with my CAN bus logger, which I actually will be making a video on very shortly because it's about ready to come to market. But getting back to today's video, I wanted to start with a simple project that was more in depth than like a simple, hello world application, right? So for the longest time, I've been using a Google Sheet that I put together for converting map sensor pressures. Not everyone posts a great graph of map sensor values, or they're in one unit and you need to switch it to another unit, vice versa. They don't have the scale, like they go from 0.5 volts to 4.5 volts and you need 0 to 5 volt, whatever you may run into. And I had a Google Sheet that I used for the longest time that worked perfectly for this. And I was like, you know what? I'm just going to convert the Google Sheet program to an actual program that I can release on 3 operating systems. So it'd be a great way to get my feet wet, get used to deploying for Windows, Linux, and Mac computers. Excuse me. So because of that, I developed a calculator. In the description below of this video, you're going to have a link to the release page of this calculator on my GitHub. If this is an open source calculator, I'm releasing free to the community. So if you want to get your own, you can go to the link, open up the assets, and then grab the zip file, unzip it to your computer, and launch it. There is a little snippet of what you need to do to get the calculator going underneath each one of these. I know most of my viewers are probably running Windows. You can unzip the folder. I normally unzip it to my documents folder, and then I shortcut the application to my desktop, just as it's said right here. For Mac users, you install it into your applications menu. And then for Linux users, you unzip the file, and then you just drag and drop it to your desktop. It is a app image, so it's all compressed into one file, and you open it up. So going with that, I'm going to show you what the application looks like. So the application is a nice small little window here, right? So it has an about, a help menu to give you an idea of what's going on, and then just like a simple close. And then the rest of this is actually the calculator itself. So we're going to bring up low dollar motorsports map sensor area. I use a lot of low dollar motorsports map sensors on my projects. A lot of the stuff I'm going to be releasing with Twisted Builds is going to have native support for a lot of low dollar motorsports sensors. The boost controller I have coming out soon, which is going to be the Simple Dollar Boost 2.0, has 3-bar and 4-bar map sensor functionality built right in, so you can select it and go. There's no custom input. If you want to use a different input with it, you'll be able to go into the custom area. I will release another video about the boost controller eventually. However, we're going to use this. I'm also going to show you some Rife sensors, because I had that brought up in a poll I had on my Facebook page, that a lot of my potential customers use low dollar motorsports and Rife sensors. So, say for instance, you wanted to take a vehicle sensor off a vehicle and make your own sensor graph for it using a mechanical pressure gauge or vacuum gauge to build your own graph. This calculator is going to be awesome for doing that, right? So we're going to go to Low Dollar Motorsports' instruction area, and we're going to look at their calibration tables. So Low Dollar is awesome, where they supply the 0.5 volt to 4.5 volt, which is the working area of the sensor. But for some factory computers, some other systems that require 0 to 5 volt values, they also give you those as well. So just to show you how well this calculator works, we're going to bring the calculator up, and I'm going to, we're going to use the 3-bar input right here, okay? So whenever you see a negative value, okay, that negative value is gauge pressure. So absolute pressure, like this right here, is always going to start at 0, which is absolute 0 pretty much, and go up. Atmospheric pressure obviously is 14.7 psi. Gauge pressure, we read that at 0, or technically 14.5 is what $1 says it's at, and it's 100 kPa, right? So say for instance we didn't have the 0 to 5 volt values, and we needed those from a 0.5 to 4.5 volt sensor. We're going to use their PSI, so we're going to set this calculator up to PSI. Low pressure is going to be negative 14.5. Low voltage is we're going to leave at 0. High pressure is the 29 right here, right? So we're going to grab 29.0 and a high voltage of 4.5 volts. So that is getting from here, right? And you can do the same thing. Like if you hook up a pressure gauge that's an oddball factory sensor, maybe you got from a junkyard or you got a new one, with no graph, you have no data on it, and you get one of those little hand pumps that can do vacuum and pressure. You can hook your voltmeter up to the signal wire and ground, and then you can pull vacuum or pressure and kPa or PSI. I know most of the ones we're going to have in America are going to be PSI, right? And you can apply a vacuum, get a voltage, apply high pressure, get a voltage, and you can use this calculator to graph everything out. So we're going to leave voltage at 0 because say, for instance, we had... Oh, wait, this is a half volt, not 0 volt. 0.5. There we go. So that'll match everything here, okay? Say we needed the pressure, the gauge pressure. We're going to do it in PSI at 0 volts, okay? Calculate. It's going to say 1994. If you notice, 1994, okay? Now, say for instance we needed the pressure, the gauge pressure at 5 volts because again, say we didn't have it, right, and we needed it. 5.0 volts. Calculate, or you can hit enter. 34.44. Oh, look at that. It matches. Isn't that beautiful? So say for instance we needed you're pretty much never going to get gauge pressure and kPa, but I did offer that as a thing. You're normally going to get it in absolute for kPa is almost always absolute. Gauge is almost always PSI. However, I love freedom, and I gave everyone the option to fiddle with whatever they wanted, right? So absolute pressure would have been 49. PSI would be 34. There you go. So now say, for instance, we go and get a sensor that does not have a 0 to 5 volt, but we're going to hook it up to a factory computer that has a 0 to 5 volt input, okay? We're going to pick on Rife for a minute, because Rife from Motion Raceworks does give us a graph right here, which works with like Holley and Holley Terminator X and stuff like that, right? Mega Squirt, stuff like that. We can put that graph voltage in and we'd be fine. However, if you wanted to hook this sensor up to a factory computer that used 0 to 5 volt, you don't have the data here to do that, right? We have the pressure gauge. We have the voltage from 0.5 volt to 4.5, but we need 0 and we need 5. I'm going to bring the calculator back up, okay? So we're going to take, again, 0.5 volt. That's 14.5. So it's the same sensor pretty much, 4.5 volt and 29. Again, 0.00 volts. You can get your gauge pressure to put at 0 volts. It'd be negative 19.94 and 5.00. Calculate it again. You get your 34.44, and you would use both of those inputs as your 0 volt and 5 volt input to like a factory engine computer tune up or whatever you're doing, right? If you need a 0 to 5 volt. So there you go. That is a simple way of doing it. And again, this has PSI gauge, kPa absolute, PSI absolute, and kPa gauge for your input. So you just change it to whatever you need. Most people, I'm assuming, are going to use PSI gauge. But I also wanted to give a kPa absolute. That way, if you're running this right here, you have the ability to go from kPa absolute to PSI gauge and get your gauge readings in PSI as well. So I hope this helps a lot of people. I have enjoyed it. I have this application installed on all my tuning laptops or whatever I do for any of my electrical shenanigans with map sensors. This calculator can come in handy if you're going to be using the Twisted Builds boost controller coming out soon, the new V2 of the Simple Dollar Boost. If you need to convert, because it's going to use 0 to 5 volt PSI readings. So again, if you get a map sensor, or you're using a map sensor that works at 0.5 volt to 4.5 volt, you can use this calculator to get your 0 to 5 volt reading to make everything line up. Or again, whatever you want to use this calculator for. It's free to use. It's open source. All the source code is posted on the GitHub. You can go to the GitHub and go just right here and get and download everything to play with it yourself. I used Qt.io to compile it. I guess that's it. So, thank you for watching this video. If you like it, please like and subscribe, and I'll see you on the next one. Bye.